I'm sure there'll be so many ideas being shared on stage. You'll have so many questions as well. So we have to aim for a full house so that when people walk in, they can take the back rows. Thank you. I see some movement. That's promising. So in the morning, when I introduced the Future Earth Summit for today, I had mentioned a few focus areas, and the first of it was advancement of renewable energy sources. And we are going to do justice to that point very well in this afternoon because, as I mentioned, we have 7 expert speakers coming on stage, representing various sectors or, let's say, various aspects of this topic. And it's going to be a lot of ideas coming on stage today that's going to fuel our future, quite literally. This session is named Fueling the Future, Green Initiatives and the Promise of Hydrogen Revolution. And it's my pleasure to bring on stage our speakers one by one. Let me start with Shri K.R. Jyothilal, IAS, Additional Chief Secretary, Govt of Kerala. Hearty welcome, sir. Yes, I'll call all of them one by one. Dr. Ranjit Krishna Pai, F-level scientist with DST, Govt of India. Hearty welcome, sir. Dr. G.V. Shankar, Senior Advisor and Consultant with Axiom. So, Shri Sudarshan Suryawanshi, Chief Operating Officer of Axiom India. Dr. Mukul Dubey, Principal Scientist and Head of Sardar Patel Renewable Energy Institute. Welcome, sir. Mr. Deepu Surendran, Chief General Manager of Cochin Shipyard Limited. Hearty welcome, sir. Professor Mahaveer Kurkuri, Associate Director of Center for Research in Functional Materials with Jain University. Our first speaker from this panel is a senior IAS officer whose leadership has been vital in advancing the state's energy policies and development projects. Very proud to present to you Shri K.R. Jyothilal, IAS. Do you want to follow the panel discussion format or
first to make a
presentation? Okay.
Yeah.
This is your slide change.
Which one?
Forward.
Okay. Thank you for giving an opportunity to share some of the thoughts what we are doing. Respected Mr. Pai and other Shankar and friends. Yeah, okay, thank you. Thank you, Jain University, for organizing such a wonderful event. It is said that you don't worry about the past because past is past. Don't worry about the future because future is what? Uncertain. But worry about the present. Present what you need to do because present contains both the past as well as the future. So this is where I think what we are doing at present so that our future will be great. In fact, we are living in an age where there is a lot of disruption. In fact, in the world of business, first disruption was the spice trade. People thought that spice will keep their food, preserve it. Later on, they realized that refrigeration is only that you are not knowing the taste difference. Then I think refrigeration, ice companies have come up across the globe. Then later on refrigeration, now even that is also getting disrupted. We are in the last and lasting disruption stage of this year, this century, whether it is AI or all the robotics and energy transition. The AI as well as the data centers are going to consume power almost 10 times. So I think a lot of investment, alternate investment funds are all taking out money from SaaS companies and putting in the renewable energy. Not that they like decarbonization and Kerala being the largest, probably we supplied the manpower to carbonize the world. almost 30 to 35 lakh. So we even to decarbonize the world, I am sure Kerala can. That is where the relevance of skilling and education centers and universities have got a great role to play. We can skill the manpower for the global requirement. I think global skilling center for the decarbonizing the world can be supplied by Kerala. In fact, let me tell you, IMEC is already, we are working with them. The entire globe, I think you can have a, like International Solar Alliance was looking at connecting the entire world. You can ship the sunshine. If you can put a cable across, Australia and Singapore is already working on it. Singapore and India, India to Middle East, Middle East to Europe, and then US. The entire world can be powered using solar. So first let me, before starting, my obeisance to the three sages of the world, I think, which I always respect. One is, maybe we are in the Cochin. This is where Shankaracharya's place. Mass and energy are not same. This is what Einstein did a lot of research. Now we know that, you can, your entire body is electric. Even all of your cells are electric. Your body itself is the greatest, maybe hydrogen fuel cell, you can tell. That mitochondria which is generating the power. You are using biomass, carbohydrate. The entire process, we should learn from that. I think this is where when you talk about energy. Second is Sage Vishwamitra, who did penance in Kerala and got the Gayatri Mantra, which starts with Om Bhur Bhuva Swaha. The world is nothing but materialization, vibration and radiation. So the radiation, whether it is solar radiation or it is a material, that is whether it is molecule, whether it is hydrogen, methanol or ethanol or so ammonia or liquid hydrogen in the long run, which we use now in the rockets, or it's electrons, which like we are getting now as electricity. So all the three are nothing but you need to look at, the world is now looking at open energy integrated smart grids. The energy grids and gas grids and are nothing but it needs to be integrated. We need to look at that. So open, this is a second sage which is relevant for Kerala. And third but not the last is Sage Agastya, maybe who gave the Aditya Hridayam, which says that everything comes from, we need to learn from the hydrogen becomes helium in the sun. We always talk about the fission, how the fusion reactors can be brought. Okay, thorium is one deposit, we have got the largest deposit of thorium. How best we can do it? SMR technology is now up to 50 to 100 megawatt. Easily you can make in maybe 50 acres of land is enough. Now Government of India is also bringing out policies so that you can have to carbon neutrality by Kerala government has announced that we would like to become carbon neutral by 2050. That means 20 years ahead of the rest of India. Though 2070 is the target which the Government of India has put. So I think that will be possible provided we go for all sources of energy, including nuclear. Now coming back to some of the points, I think I'm not getting into the details because most of it you'll be knowing that we have got mainly hydel projects and we roughly meet around 27 to 28% of our requirement from the hydel projects. But we have got huge potential for floating solar as well as the pumped hydro. Roughly around 6,000 megawatt is what we estimated. The government policy is in the final stage. Second is pumped hydro, almost 8,000 megawatt. Pumped hydro potential is available using the existing reservoirs. That is the second. Then third one was the wind. In fact, Ramakal, Med and Palghat, roughly around 15 meter height, we have got something around 2,750 megawatt. That's a potential. Now this I already covered. We want to be net zero by 2050 and 100% RE by 2040. And we want to have already a hydrogen hub for Kochi and Vidinyam DPR has been prepared by MEC Intelligence. We have done the estimation, roughly around 1.5 lakh existing domestic demand itself is there, refinery is there, already Air Products is invested in that they make from hydrogen from the natural gas. Then FACT, ammonia they are importing. In fact, world's largest import of ammonia is only into one country, that is India. That is almost 21.2% of the world's import of ammonia is there to India. So that itself shows that enough domestic demand is there. That's why the hydrogen ecosystem will be a successful. Then earlier Europe was thinking in terms of like Morocco. But Morocco, if if there is a purchase contract doesn't go through, where will they use the hydrogen? So that's why I think a lot of investment, what was proposed by Europe, had to be withdrawn. In fact, the banking sector, they asked for insurance coverage. And that won't happen. At least we have got enough demand within the country itself. Then the adequate transmission infrastructure. We are now looking at maybe 10 gigawatt CTU capacity, so that these ports, any investment, ISTS charges have been waived by Government of India, so we have got, we will have enough, CTU as well as the STU capacity, so that, any industry can make use of the open access and have green hydrogen production. Then knowledge-based industries, I think Kerala is also has got that, it is a literate state. Only thing we need to higher education, probably we didn't move with the time, but now universities like Jain and Christ and Amrita, all of them are actually, two of them are from Kerala itself. So I think they are bringing that change. And ASAP and CASE by government initiatives, skilling both from the maybe ITA level upwards, skilling you need to, generally it is said that either you skill development or S, instead of S coming, if it comes at the end, it kills development. So we need to have that, and the Dr. Pai is here. We are working on a triple helix structure of bringing the industry, the academia, as well as the research together. Because earlier, these are all like three pillars, India, Pakistan, China. We are always fighting, or we never used to interact with each other. I think the triple helix, what we have learned is from Netherlands, how they brought beautifully the industry, academia, and research together. I think that project has been, 4 states have been selected. We are one of that. We are thankful to Government of India for making Kerala Hydrogen Valley Innovation Cluster, where I think Dr. Shankar is here. We are working on some cutting edge technologies by which we can make the hydrogen which is cheaper than probably the diesel. Already Travancore Cochin Chemicals is there. They are able to give hydrogen at 98% purity at 180 rupees. If it is below 280 rupees, means it is profitable. Only thing, the purity was one issue. For hydrogen ICE engine, which I think Reliance is already, along with Ashok Leyland, has developed, you can run a ICE engine at cheaper than a diesel. Only 10 to 12 lakhs you need a conversion. For a conversion cost for a diesel or a CNG bus to convert into hydrogen ICE will be roughly 10 to 12 lakhs. So I think that's economics is in favor. But we need to, how green hydrogen can also be less than maybe 200 rupees, that is a challenge. In fact, there are companies, in fact, we came across 1 or 2 companies which have already gone up to TRL level 6, where membraneless electrolyzers and direct splitting of water using sunlight. So those are all technology, these are areas where I think we need to work together. The R&D needs to be supported. Another important area was storage. How do you store these hydrogen in a gas form, or you can liquefy it, or how do you reduce the cost of liquefaction or cost of storage? That is where I think Axiom has brought a technology by which you can store in the metal hydride form. I saw one Israeli company which takes just like a coffee powder, you can store it in the coffee powder form. Canister, now Toyota is bringing that you can, energy you can carry in the canister form, and you can, just like electric vehicle, you can just put the energy canister so that it can be charged instead of battery. So I think these are all technologies which are evolving. We are in the, in the cusp of new age which is emerging, where you are able to generate your own power. I always used to say, man can live from atmic energy to up to atomic energy. The entire spectrum we need to look at it. So I think it's slowly happening. Last time the Energy Observer of France was here. I think we were the 75th country in the world where it has touched. It has come to Kochi. They don't use any. They have gone to 75 countries, but they never used any fuel. One is solar, second is wind, third one they take the water from the sea. They purify it, desalinate it, they drink, they use for cooking everything inside the yacht. The energy observer, they are using that only. They have got only hydrogen fuel cell as well as the battery. How a mix of energy, whether it is solar, wind or hydrogen and battery, can solve all the problem. In fact, they say once you come inside the Kochi, only they say the water is very much polluted. So water is a symbol of love. I think because with our mind pollution, I think water also get polluted. Now I came across another research person who has patented a technology. Now Keralites we have got original, this is the age of artificial intelligence, but I think we have got original intelligence within 48 hours, any water which falls on Kerala, we make it a dirty water. That much original intelligence Malayalis have got. Then this guy said, this German fellow, he said WME, his company name is WME. In fact, Mr. Wattel, who he only sent to me, who did the Central Vista, he says, any dirty water you give me, I will make it fresh water using solar or wind. In fact, so I think probably all the lakes, we should be able to get it cleaned. And in fact, last World Hydrogen Summit, one of our colleges got the hackathon only on this ground. They said how I can use the STP water, 100 mld STP water from the water authorities, like it is called Water and Wastewater Authority. How to convert water into wastewater is also our core competence. So that wastewater, 100 mld, he will convert into fresh water which can be used for hydrogen, so that there is no need for additional fresh water for hydrogen generation. I think that's another good initiative probably some of the colleges have taken. Now, these are, maybe I am not getting into details. So PM Kusum, we are targeting 1 lakh solar pumps, and PM Suryagar, probably this is one project which we have got 99.2% growth rate in last 1 year in solar installation in rooftop. Probably I don't think any other state can match with maybe our base is less. Almost 250 megawatt has been added to I should thank all the people who have participated in that. Roughly around 67,000 houses have gone for solar, rooftop solar in last 1 year. We are looking at 10 lakh people to be covered. Then green income scheme we give to the BPL families up to 3 kilowatt. 1 lakh houses we are targeting. Floating solar, I said. Private investment, if we add, roughly around 6,000 megawatt is what we are looking at. Then electric vehicle, 1 million electric vehicle, out of which I think we already crossed 2.5 lakhs target. In fact, the highest growth rate of EV in India is in Kerala, mainly in the two-wheelers, almost 12% growth rate. And that too without any subsidy. Only infrastructure is the main incentive. There is no subsidy which you are giving. Then green hydrogen I have already covered, 5 lakh tons per annum is what we are looking at. Then 90,000 jobs we plan to create by 2030 and 1.67 lakhs by 2040. So I think the various, stage right from ITI to Polytechnics to BTech to MTech and various courses have been designed. In fact, Professor Chitra Rajagopal from the IIT Delhi is helping us. Shankar is here. Then all the university, we had one round of meeting with all the universities, Jain, Christ, Amrita. So we will soon be launching new courses so that, safety is very key as far as the hydrogen economy is concerned. Standards are already there. So I think that process safety, we can offer good courses. In fact, Mr. Pai will be mentioning about after the last visit, probably how best we can, one is testing centers we need to set up across the country. As postdoctoral, I think China sends their people to, in fact, last time the IMF Deputy MD, she was mentioning, Gita Gopinath was mentioning, China sends people in bulk to the Harvard on economics. But we never thought of that. No, I think this is where they send to Netherlands, all the universities, top universities, government also funds it. So I think it's a very welcome initiative that Government of India has come forward to support in sending our postdoctoral fellows to these foreign universities so that they come with the latest knowledge in this sector. Then TNO also, probably Faraday's lab, all of them can collaborate with our research institution. I was just listening to some of the ISRO scientists. India is known for the frugal innovation. No country can match us in cost because we probably Indians, in innovation we talk about, I think I would like to just mention that Kiran Karnik, I think 5 more minutes I'll take. Yeah. Kiran Karnik, who was a NASCOM chief, he was once mentioning, India is known for best innovation. The example he has quoted is his batchmate in IIM. He started after doing MBA. He started selling washing machines in Punjab. Then he asked, how come washing machine, suddenly Punjabis have become like, very crazy for washing machine. He said, the washing machine is used for lassi making because Punjab, they drink a lot of lassi. So, whereas your mixies cannot make so much of lassi. Whereas washing machine you top and the output is directly given, the jar can be filled very fast. See, this is, I'm just giving an example, like innovations. In fact, ISRO is able to make the rockets at the lowest cost in the world. And they brought almost 250, more than 250 MSMEs have brought under that, and I think how a beautiful system they are able to make. I think our Indian scientists, given a chance, they can do wonders. So that is, I think the age for India has come. Now, coming back to the hydrogen economy, what are the areas we have identified, what all areas, like 1 gigawatt of electrolyzer plant, what all projects, or the post we will be looking for. I think this nutshell shows how much job can be created. In fact, ease of doing business, probably Kerala is ranked the number 1. Maybe now we are working on one more thing, cost of doing business. Cost means even a delay also costs. So how best we can, so that the return on investment will be the maximum. So on automotive R&D hub, because Nissan and a lot of companies are now coming forward, because R&D and research, probably India, Kerala being the birthplace of the greatest scientist ever born on earth. Let me tell you, no scientist of the world has got technology to go to sun, moon and stars. Probably the king of Kerala is the only person in the history who had tried to change the planetary position of earth, where the earth rotation got affected for a microsecond. So I think we have got the scientific bent of mind and thinking. So we should be able to lead the country and the world in science and technology. I am sure it is, if ISROs, most of the top scientists are all from our state. So why not we may leverage that? I think the time for Kerala has come, and it's happening, whether in IT parks or space technology or in the molecular biology or Sri Chitra and all these, in fact, stem cell research, etc. I think they are doing wonderful works. Why Kerala? Because I think, see, in India, all the states have got everything but except one item. If you take Himachal, they have got water, they have got gradient so that they can have pumped hydro, they can do renewable energy throughout, but no port. UP has got everything but no port. If the port is there, but they may be on the either western side or on eastern side. We are at tip of India, as Nostradamus has predicted, where the 3 oceans meet. That will be the center of the world trade of 21st century. I think the time for Kerala has come, and I think we need to develop the port infrastructure so that we didn't move with the time. I think we need to go back to the future. I think the time has come, and we need whether it is the infrastructure for the storage, the transportation, whether it is bunkering, then the big ships. That is where I think shipping, I think Cochin Shipyard is also here. We should be able to, now only 2 or 3 companies are there in the world who makes the liquid hydrogen carriers, Kawasaki, McDermott and all, LH2. I think we should be able to invest in that so that maybe roughly around 2,000 to 3,000 crores minimum it may come to design a carrier ship, so that we need not depend on another country for our export requirement. We are working with Amsterdam and Rotterdam ports, which are the largest port as far as the hydrogen economy is concerned, so that we can replicate. They have got the import terminal, same thing we need to replicate here for the export infrastructure. So Kerala has got everything, renewable energy, then port, then round the clock RE potential apart from solar and wind. Yeah, I think this is what, and you have got a refinery infrastructure which is available. Now, this is the our target, as I said, we are looking at reduction of cost to probably we may be able to come down below 200 per kg for the green hydrogen. As research suggests that, it may be possible for biomass based already for water hyacinth or any waste compressed biogas to hydrogen. Now technologies are available which makes it much more cheaper. And we have earmarked, in fact, some of the reforms on the land availability. I always used to say Kerala is a place where we couldn't give the 3 feet to Vamana, only 2 feet we could give. Probably even now we couldn't acquire the land. So land shortage is there. To address those issues, some reforms are suggested so that the clean technology companies, we should be able to give the estate areas like rubber or plantation sector, part of it we should be able to make use of for the clean energy companies. I think this is one reform which is in the pipeline. First 100 megawatt electrolyzer we will be giving subsidy so that investment will be attracted. As of now, 5 companies have approached, including Renew, Petronas, Infinity, etc. So I think there is one company recently has come, they wanted to take carbon dioxide from FACT and then generate hydrogen and make methanol, so that methanol can be used as a fuel for Kochi, for the marine applications. We have these are all some of the projects which have been approved by the ARA for running between Cochin and Trivandrum, the hydrogen trucks and HICE trucks, which is recently approved. This is a project which I was mentioning, Hydrogen Valley Innovation Clusters, where all this innovative technology, in fact, a very, very interesting thing is, generally methane is supposed to be a harmful thing. Now we have, Mr. Shankar is here, Dr. Shankar, he has brought the technology by which you make CH4, hydrogen is taken out, the carbon is deposited in nanoparticles, you can make graphene out of it. And the Global Center of Competence on Graphene is also there in set up at Trivandrum by the Digital University. They are working with them so that we can generate revenue from methane itself. And in fact, Kochi, maybe Alapi area has got a lot of peat gas. Peat deposits are there, which is nothing but, I think, methane you can convert into hydrogen and graphene, I think, or carbon black, which both has got a good market. So these are, WME is one technology which I mentioned, like, how wastewater to good water. The second is one project, 2G technology, where any gas, like a gas grid and energy grid, and you have got a city gas distribution, most of the places which are coming, gas you can convert into power, gas to or hydrogen or any compressed biogas or CNG you can convert into power. That's a cleaner. Then another one was the organic hydrogen from water hyacinth. Water hyacinth is something which I think all these water bodies are having. That I think the hydrogen will be less than 100 rupees. So these are some of the projects which are working. Then the R&D, Center of Excellence. This is another project which are working. In fact, the Government of India, MNRE has called for expression of interest. This, I think all of you know, the Water Metro, I think probably India's first hydrogen boat, Cochin Shipyard only built it, using indigenously built KPIT's fuel cell. So that is also best example of indigenization. And now they are even supplying to Samskip, which is a leading logistics company in Netherlands. And Cochin International Airport is the world's first solar airport. Now the excess solar, they are converting the wastewater from the Cochin airport, that they purify it, and it's 100% recycling. They are converting using the excess solar to hydrogen. By March of this month, I think the fueling station by BPCL will be ready. In fact, one more thing we are looking, because Kerala we don't have road width is much less because our mine width is also slightly less. So we cannot acquire so much of land. Vertical mobility, how best people can take off from maybe a family of 4 or 6 can take off. The next Global Hydrogen Summit we are having in Kochi, so that time they will be bringing the Blue Aviation. They have made an electric VTOL. You can take off from your own house and land in any place where it's a vertical landing and takeoff aircrafts. So that's ideal. It's like a flying taxi. So we are trying to put liquid hydrogen into that so that you can have a long range. So I was talking to ISRO chairman. I said that you are talking about the moon and other planets where maybe 35 light years away you can reach another planet where we can live. I said by 35 years we may not be even alive. but let us run something on earth where we can show. So a liquid hydrogen truck, and with one filling it can go up to 1,500 kilometers. So that means Kochi it starts, it can go up to Mumbai. So I think you don't need so many fueling stations. Same thing for the EVT oil. Probably we will be demonstrating in the Global Hydrogen Summit on March 12th and 13th here in Kochi. In fact, this is part of the DPR which we did for the hydrogen hub, and the level of, maybe I am not getting into details due to paucity of time. These are the sectors where we can use hydrogen, and where is the, what level is technology is available at TRL level 6 or 5 or 8 or 9. So, and I think this is probably we are one of the first states in the country to do an in-depth study about, which are routes where you can deploy the buses, and what is the economics of it, then the industries and level of company. Because unless you aggregate the demand, you will not be, you can't, this is a long gestation project. There's an early mover disadvantage as far as technology disruption is happening or technology is evolving. So I think we need to bring everybody together. So this in nutshell is what we got to talk about, the hydrogen economy, which Kerala is working on it. Let us all work together, both on the skilling side, R&D side, and the industry side. And government will be a facilitator instead of what is a, so our vision of a developed India and developed Kerala will become, and the day whoever controls the fuel controls the world. And they, in India, whether to reduce import substitution or our making our currency strong, we need to make them energy independence to energy independence. I think hydrogen is the answer, along with other maybe battery and other technologies which are like LTO, lithium ion, etc., which we are already working on it. So thank you for giving an opportunity to share some of the thoughts. Thank you.
Yes, sir. It was very nice talk. Thanks for that beautiful talk. Just one question from my side. See, the national target for net carbon zero is 2070. But you said Kerala will be net zero by 2050. So 20 years ahead of national target. So how are you going to achieve it, sir? And fact, one question you can add on to your
Kerala
answer.
Is, first, let me tell you, Kerala is one state where greenery is highest. Carbon sink is almost 30% of the area is under forest, and it so happened that I am forest secretary, additional chief secretary for forest also. So then we don't have polluting industry, and we also don't allow any polluting industry. That is Kerala's mentality is also like that. People will not allow any polluting industry. The major emission was coming from the transport sector. Now metro is there, water metro is there, all of them, the airports, they are all going green. Transportation sector, electric mobility, I said, 1 million EVs, and only sector which we found difficulty was the, long haul trucks, buses. Now we are trying both LTO battery for a fast charging, so that it becomes economically viable. Anything will be adopted unless you need to make that breakthrough so that it's affordable for everyone. So I think that is where the role of all of us, we have to work together to make sure that economics works in favor. Automatically people will adopt. As I said, electric two-wheelers, we don't give any subsidy. I said people have adopted because it is cheaper and is economically viable for them. So I think this is and we have made a roadmap for what each department has to do, each Gram Panchayat. Actually, every individual has to work together. Unless you cannot have that only one department or somebody, some limited number of people working together. So in fact, we gave target to each panchayat. 85 such panchayats have come forward. Let me tell you, all the government buildings in Trivandrum now we have gone for solar. We have done 18 megawatt in last 1 year. And we got the Shanghai award because only city in India which has got 18 megawatt installed in 1 year is all the government buildings. Now we are trying to put how, instead of the mass storage, whether we can go for storage by the masses. You need to involve the public. The battery itself can become a source of revenue for the auto owner or the two-wheeler owner. Yeah. So that is where I think it's happening.
Amazing example for other states, sir. I really have to comment this one. And another quick question is, what about government initiatives to industries, etc.? Are there any subsidies? why they opt, green hydrogen, which is very expensive compared to fossil fuel right now?
Yeah, in fact, we put something around 200 crores has been announced in the last budget as a viability gap funding. That's where I said, first 100 megawatt electrolyzer, because we are not a state which is very, very comfortable, because our slightly, maybe economically we are maybe our growth rate is good, but people are rich, but government is poor. So we need to have within our capacity whatever support we can give for the infrastructure side. Instead of giving subsidy directly, like IRA, they are giving $2. It's not sustainable. The moment the government changed, Trump came, everything is washed out. Instead, had it been infrastructure, like I give infrastructure support, say for example, storage, bunkering, pipeline, technological development, these are all things which are going to make the sustainable changes. In fact, let me tell you, World Economic Forum at Davos has taken Kochi Hydrogen Hub as a model for the last World Hydrogen Summit. I think today probably the announcement may come. World Economic Forum itself has accepted that this is within the means how people should come together and make disruptive technologies, only technology and infrastructure support. And
that's amazing achievement, sir. So just let you all know that 2050 is the target for net zero for most of the developed countries. So it's really amazing news to know. So are there any questions from other panelists to Jyothilal sir? Or maybe from audience? Okay, so maybe we can go to next presentation from Dr. Ranjit Krishna Pai from Department of Science and Technology, Government of India. And I can request other panel members to maybe sit to see the slides.
So good afternoon, everyone. So I'm happy to be here, representative of Department of Science and Technology. And today I will be presenting DST's Clean Research Initiative, especially Hydrogen and Fuel Cell Program, which I'm handling at DST. So in India, the way of operation concerned with the Ministry of Science and Technology, which in turn comprises the Department of Science and Technology, then Department of Biotechnology, and CSIR. So these have been the three main operational agencies. But apart from this, governmental funding is not only comprised of this, although we are going to look mainly at what these agencies are doing. So there is a lot of other opportunities such as MNRE, MOP, and public sector unit that comes under the government. So Ministry of Petroleum and Natural Gas is becoming a very key player in the transition to renewable resources, and especially from the transition from petroleum to natural gas to hydrogen. And then we have Ministry of Earth Science, DSIR, and so on. So all these governmental agencies are coming and putting forces their input, although the main execution agencies as far as the hydrogen and fuel cell program is concerned is the Department of Science and Technology. Further, India presented the following 5 nectar elements of India's climate action. So our Prime Minister introduces India's Panchamrit at COP26 in Glasgow. So India to achieve net zero status by 2070, India to achieve a reduction of 1 billion tons of CO2 emission by 2030, India to reach 500 gigawatts of non-fossil energy capacity by 2030. So 50% of its energy requirement from renewable energy by 2030. And India to reduce its emission intensity of GDP by 45% by 2030. So vision of clean energy is to support upstream end of the research to generate advanced knowledge for potential application of clean energy, to develop a baskets of R&D-led solution for low carbon emission technologies, pilot scale deployment of lab-proven clean energy technology for techno-economic evaluation in partnership with industry as technology providers for accelerating the technology to higher TRL level and market readiness. And finally, to promote national, bilateral and multilateral collaboration between academic, utilities and other stakeholders, adaptation of global best practice and technology acceleration. Climate, Energy and Sustainable Technology Division seek to strengthen national and international cooperation of social deployment and development, particularly in the thematic area, carbon capture and utilization and storage, climate change, clean and alternative fuels, clean coal, smart grid, building energy efficiency, and solar energy system. So the main program, which is material for energy storage and hydrogen and fuel cell program, which I am handling. Today my talk will be mainly on hydrogen and fuel cell program. So before starting to the National Hydrogen Fuel Cell Program, I would like to talk about something about mission innovation, because most of the national program is coming under mission innovation. So what is mission innovation? So the whole concept of mission innovation started in November 2015, when the heads of various different governments, including India, represented by our Prime Minister, Sri Narendra Modi. Mission Innovation Platform is one of the most powerful and enabling platform which brings a lot of countries and a lot of technologies on board and enable collaborations and collaborative effort to take on challenges that are global importance. So, and in that context, Mission Innovation 2 was launched to accelerate technology, particularly with the emphasis on Paris Accord, which India is a part to. And that is the main idea, is to reduce the global warming. And that is where the energy becomes a very important part of this entire cycle. Since Mission Innovation was announced, Material for Energy focused on identifying opportunities to support these 4 missions and one of the innovation community and their unique material needs. So some of those ideas are reflected in this slide. So if we appreciate that, each mission innovation initiative is at slightly different stage of development. So Material for Energy would like to participate in your individual roadmap in order to prepare to assess whether material acceleration platform could be applied to solve material problems that would advance you towards your goal. So in some cases, we are already developing the self-driving lab to address missions need, particularly for hydrogen and carbon dioxide reduction. So there is also a major project on battery storage under Horizon 2020 known as Big Map that works within the Material for Energy broader ecosystem. So one of our earliest intervention was on thermal energy storage material, and we would certainly be interested in deploying the workforce developed with the affordable heating and cooling of building innovation community in this phase of mission innovation. So in order to get an idea of how material acceleration platform could work for developing electrocatalyst for the clean hydrogen mission, let us consider the electrocatalyst system under development by the National Research Council of Canada. Here we could see that the schematic shows the closed-looped catalyst synthesis and characterization to achieve oxygen reduction using a low-cost metal oxide material. Artificial intelligence will be used to accelerate the electrochemical characterization, but also plan the next experiment from the available elements or candidate material space. So this system can be directly applied to hydrogen production, and there are plans to integrate this in the future DST programs. So hopefully it will support under the clean hydrogen mission. So the ongoing program that we have stepped into now is focusing more and more faster innovation to bring the translational project into reality and at the same time do it in a cost-effective manner. So that was the challenges that the DST started out when it decided to take on the integrated clean energy material acceleration platform. So we shorten as IC map. Here we could see that IC map is divided into 3 verticals. Let's say bioenergy and hydrogen map, material map and storage map. And if you see, each map has a number of PIs on board. 10 PIs comprising bioenergy and hydrogen map, and each of this has a very direct and concrete connection to our commitment to Paris Accord. So I should also mention that as far as the Indian contest, this has been a program that right from the start, it has taken up top-down approach. So it is a goal-oriented mission-made program, which we are trying to achieve through this. And what is common between the 3 verticals is that every single vertical has a very strong role of artificial intelligence, machine learning, and data analytic that is inbuilt of each of these verticals, so that actually enable in silico processing, not only the data mining, through integrated clean energy material acceleration platform, we have access to a large databases. And though the most of it done in a productive manner, rather than trying to do an experiment and to understand the results. So it is now become inverted, where the machine learning and data analytic combined with the artificial intelligence is now trying to guide the entire program and enable the material discovery at a faster pace and at more cost-effective manner. So the other main aspect of this is a translational implementation. So it is always stressed on how is this technology, the concept that you have developed, going to translate to ground reality, and this has also been factored in these 3 verticals. So DST has taken up deployment of hydrogen and fuel cell technology program in 2018, and the focus is on creating volume and infrastructure towards demonstrating of niche applications. So I'm not going to read all the program you can see here. We have advanced hydrogen and fuel cell program. We have some bilateral program like Indo-Danish joint call in green hydrogen. Then finally, we have Hydrogen Valley Innovation Cluster recommended by DST. So under HVAC call, means Hydrogen Valley Innovation Cluster call, there are 4 valleys are under consideration, and the fund is making available 50 crore per valley, and final funding decisions are expected by March or April 2025. So here are some of the areas supported under DST's ongoing program under hydrogen productions, hydrogen storage and distribution, and hydrogen utilization. DST also supported very important 2 platforms. It's called MECSP platform. One is we funded to IIT Mumbai for energy storage platform on hydrogen. It has been established to carry out material and system research, prototype demonstration, and technology development. And the lead organization is IIT Mumbai, and 4 partnering institutions. Here you can see that IIT Guwahati, IIT Kanpur, Tirupati, and NIT Roorkela. So the technology called metal hydride-based hydrogen purification system developed under this center has been transferred to NTPC. Then another center we call NFTDC in Hyderabad, and this center is established at the Non-Ferrous Material Technology Development Center at Hyderabad with a core theme of hydrogen-based material to energy devices. And the focus of this center will be a specific hydrogen-related system. Here we could see the network of researchers engaged in center comprises scientists from Bangalore, IIC Bangalore, IIT Madras, IIT Bhubaneswar, and Sri Chitra Tirunal College of Engineering. So we have supported almost 9 crore has been sanctioned by DST to support this Center of Excellence. Some of the, before going into the Hydrogen Valley, I would also want to show some of the key outcome from our DST project. here we could see that Banaras Hindu University has developed a technology called quantum-powered green hydrogen production with a photocatalytic system for efficient green generation, achieving a production rate of 1 liter per minute using 10 gram of quantum photocatalyst. And this technology has been transferred to Apparat Engineer Private Limited, and this technology was approved for large-scale implementation by the Indian Navy headquarters, joining hands with Quasar Investment Company, UAE. So this is the technology developed under IIT Mumbai. The lead PI is Dr. Pratibha Sharma. They have developed metal hydride-based multi-state hydrogen purification system, capacity of 6,000 to 10,000 liter per batch, developing 99.9 purity, using low-grade thermal input in the range of 30 to 50 degrees Celsius. And this technology is also transferred to National Thermal Power Corporation. Here's some other outcome also coming from IIT Mumbai, metal hydride-based hydrogen storage system for two-wheelers. Now, the main topic today is because I need to talk about Hydrogen Valley, because one of the Hydrogen Valley Innovation Cluster is recommended in Kerala state. So it's very important to know to all these students and faculty what is Hydrogen Valley. And we are looking forward, a lot of manpower which DST can train them. So we are coming up with the 30 fellowship program for faculty, joint PhD program, and postdoctoral program. So in order to, before explaining what is HVIC, I would like to talk about what is Hydrogen Valley first. So a hydrogen valley is a mini hydrogen economy that integrate several steps of the value chain and various end users in a regionally defined scope. So in the past, we have seen demonstration project mostly focusing on single application. But Hydrogen Valley is the next development step. So it showcases the full potential of hydrogen as an energy vector. So the objective of Hydrogen Valley is to demonstrate how technology development in the entire value chain of hydrogen, such as production, storage, and transportation, as an energy vector fit together in an integrated system approach. So through industrial deployment at a very small scale, we are starting with 2 tons per day and 500 tons per annum. So this concept as a national initiative to foster green hydrogen transition has been taken up by the Department of Science and Technology for showcasing and deploying technology advancement at the industrial level across the green hydrogen value chain and to create interconnected hydrogen ecosystem across selected region of India. We have selected 4 regions I am going to explain you. So as a clear sign of growing and maturing hydrogen market, Hydrogen Valley has started to emerge all around the world. So this slide shows the global Hydrogen Valley activities and example project from the Mission Innovation Hydrogen Valley platform. Here we could see that a total of 98 Hydrogen Valley in 36 countries with a total investment of 1,73,429 million euro. Now India is also coming up with the 4 valleys that will be added up. So mission members together with, India is also the member, together commit to delivering at least 100 large-scale integrated clean hydrogen valley worldwide by 2030. We are in 2025, this already 98 valleys are already come up. So these will generate economies of scale, pushing down the clean hydrogen cost to catalyze the development of a global clean hydrogen economy. So what makes a hydrogen valley? So in all the hydrogen valley, the concepts are unique and depends on the specific objective and regional circumstances. So there are common characteristics of what constitute a hydrogen valley. Let us look into the first large in scale. So all hydrogen valley go beyond R&D and demonstration. They are large in scale and have at least a double-digit million euro investment in size. So it typically also includes several sub-projects that make up the larger valley portfolio. And secondly, they have a clearly defined geographic scope. So hydrogen valleys are hydrogen ecosystem that covers a specific geography. Their footprint can range from a local or a regional focus, for example, major port and its hinterland, and to a specific national or international region, for example, a transport corridor along a major waterway. And third, a broad value chain coverage. It is also a very important because along their geographic scope, hydrogen valley cover a multiple step in the hydrogen value chain. So ranging from hydrogen production to the subsequent storage of hydrogen and distribution to off-takers via various methods of transport. Then fourth is supply to various end sectors. So hydrogen valley usually showcases the versatility of hydrogen by supplying ideally several sectors in their geography such as mobility, industry, and energy end users. So thus, hydrogen valley are ecosystem or a cluster where various final applications share a common hydrogen supply infrastructure. So therefore, creating a synergy and more economic setup for the participants. Finally, the project feasibility. So projects have to be under real development and at least working on a feasibility study. So Hydrogen Valley focuses on green hydrogen for various end users in mobility, industry, and end sectors. Here we could see that upstream refers to an annual green hydrogen production of 8.5 million metric ton. This is the global status I'm talking about. And the main type of water electrolysis technology used here is PEM and alkaline. So midstream is the transportation of storage of hydrogen. Storage method mainly compressed gas, hydrogen, cylinders, caverns, and others, and transportation via pipeline, truck, and ship. Then downstream pay attention to industrial off-takers for mobility and users and energy end users. So location for setting up Hydrogen Valley. So the Hydrogen Valley need to be centrally located in a region where there is a robust demand and multiple takers for the hydrogen produced. So for example, green electricity will be supplied from a solar plant located within the premises of Hydrogen Valley platform. So this green energy will be used to power an electrolyzer, which will in turn generate a green hydrogen production. The hydrogen generated would then be used in multiple applications ranging from power generation, microgrids, locomotive, and fertilizer manufacture. So being a pilot demonstration for Hydrogen Valley, the volume of hydrogen generated would be less and would also be consumed locally by customers. So therefore, a mix of high pressure storage in combination with cylinders or pipeline for local transport would be an ideal. The main scientific priority and challenges for the different pillars and activities are listed here. I'm not going to read this slide. You can see here under hydrogen production, water electrolysis will be the main technology. Then you can see the hydrogen storage and distribution. Then hydrogen end users and transport. And finally, hydrogen end users, clean heat and power. So Hydrogen Valley terms and definitions. So, however, across different nations around the globe and the evolving hydrogen economy in them, different terms and definitions have developed. So, these include primarily hydrogen hubs. We can see some in United States and Australia, they're called as hydrogen hubs. Then hydrogen clusters, which we can see in China, Australia, and some part of the Europe, and hydrogen ecosystem also seen in some part of the Europe. So while the outline characteristic of a hydrogen valley not necessarily apply to all the project labeled under this definition, they most often have at least one of the following attribute in common. So DST also expect to follow similar strategy for let's say hydrogen hubs or a cluster we called as a hydrogen valley innovation cluster as a local agglomeration of various hydrogen users and shared infrastructures and joint supply sources are essential to scale the industry and take the new hydrogen economy to the next level. Jyothilal sir has already showed the Kerala Hydrogen Valley and how many users are involved. You can see many industries are very important industries also involved in that. So this I'm going to skip this slide because this, yeah. Dr. Mahaveer was asking one question during the, after the Jyothilal sir has, why the cost is too high. So you see many of the, for example, electrolyzer, stacks and all coming from, abroad. We have to indigenously develop to reduce the cost. So let's say in terms of electrolyzer, there are a lot of companies working on producing alkaline electrolyzer in India even today, but they are only assembling the electrolyzer. So 90% of the people who produce alkaline electrolyzer in India, the stacks, they are brought from China. In the case of PEM, also the stack is coming from outside. Some of the startup has started, assembling, or some are indigenously developing also. They are in the nascent stage. And the second most important part is the rectifier and transformer. Though a lot of transformers are made in India, rectifiers are still important. So if these all components we have indigenously developed in India, of course we can reduce the cost. So these are the recommended HVAC. Here we can see that HVAC, IIT Jodhpur, we have recommended one, and you can see the lead applicant is IIT Jodhpur. Then we have Pune HVAC, Bhubaneswar HVAC, and Kerala HVAC. So ANERT is leading, so we made it ANERT HVAC. And these are the summary slides. 4 recommended HVAC is coming up soon. We are hoping March we will be, our Prime Minister will be launching, officially announcing these 4 valleys. So in this slide I have summarized these 4 valleys. These are their production route, then production capacity, then storage and distribution. There are some, I think Pune is going to use the compressed storage. Odisha will be pressurized container. Again, Jodhpur is compressed storage. And Kerala will be compressed storage and metal hydride. And these are the utilization. Yeah. Now, this is the last slide. One more slide is the last 2 slides I would like to wind up my talk here. DST's Hydrogen Valley Fellowship Program. This is the upcoming program. It's very important for the faculty as well as the student. Here you can see the objective. Objective is to foster global collaboration, enhance research capability, and accelerate the development of Hydrogen Valley Initiative in India by facilitating knowledge exchange and skill development through structured fellowship program. Here are some of the suggested topics. We are also conducting one brainstorming section to identifying the priority area on March 7th at DST. We will be inviting all the industries and many of the experts to identify the areas. So fellowship will be, the next slide will be more clear. We will be coming up with 30 fellowship, academic faculty, that is duration of 1 year at University of Groningen. Then joint postdoctoral fellowship, that is 10 in numbers. Total duration will be 2 years. At least the PhD students have to be spent at least 1 year at Groningen University, maximum of 2 years, because 2 years will be in India and 2 years will be in Netherlands. Then we also having joint doctorate PhD program and joint postdoctoral program. So the University of Groningen will not charge any bench fees. So here you can see the funding agency will be mainly Department of Science and Technology. And top-up funding for joint postdoctoral and joint doctorate fellowship, DST will provide top-up funding during the stage at Groningen. For example, if you don't understand what is that, you see the PhD student who is already getting a fellowship from CSIR or from the project. But apart from this, if you visit that 2 years, you will get additional top-up money. For example, University of Groningen has committed to give 500 euro, and DST will be giving 1,000 euro. So total 15 euro will be given per month, and you don't have to give any fees over there. Yeah, at present, the Department of Science and Technology is working on reducing the gap between academic research and market demand, which is a major challenge that needs to be overcome. So a project that involves the contribution of academy and companies may be encouraged and made mandatory in the near future. So this would enable development of innovative and path-breaking technology, and in the longer run, and enable our country to license technology and become a knowledge hub. And further, PhD scholars and students may be directed to carry out internship. We are already having such program called IRDFE Fellowship with companies for a short period, so that they would be much more aware of the requisite for large-scale production. And the companies might also want to be hire a potential candidate based on their performance. Right now, we are giving almost 75,000 plus laptop and in IRDFE Fellowship. Once they finish the 1 year of postdoctoral fellowship trained at industry, the industry will hire them. So our country has a vast talent pool and very capable research group. So now the DST can take effort to identifying a potential research group working on the same hydrogen system and initiate a joint project and startup to achieve this specific target. And thank you for your kind attention. Yeah.
Yeah, it was a nice talk and very informative, Dr. Ranjit. One or two quick questions to Ranjit. So you said HVIC, Hydrogen Valley Innovation Clusters. What was the criteria to get these HVICs? So whether state government's involvement was mandatory?
No, it was not mandatory for involving the state government, but there was several factors that was mandatory. For example, production capacity. So they should produce the hydrogen minimum of 2 tons per annum, per day, and 500 tons per annum. And most of the technology, because for example, alkaline, or we have to use the cheapest route, because that is how we have to reduce, for example, biomass route. So if you use such type of technology, so cost is very important. You have to produce the hydrogen which is reasonable rate compared with the other source. By renewable it should, so we did not put any cost there, but you have to use at least the technology which you can produce hydrogen in a reasonable cost. Okay. But also there was mandatory for the industry to participate, and industry contribution was compulsory. Yeah. So these are the criteria.
Yeah, we got it. And what is the frequency of deployment of these HVICs in the country? Is it annually?
Next call.
Yeah.
You see, after this commissioning, now you see, DST actually want to take up the complete, but you see, National Green Hydrogen Mission was launched by MNRE. Now, we all are government. We cannot tell you are DST, you are MNRE. So government, our PMO told that we have to bring under HVIC under, National Green Hydrogen Mission. So now, MNRE's plan was to launch call for hub. Now, we have internally had a lot of discussion. Now, we are not going to have hub soon. This 4 HVIC, which DST has selected, will be the pilot, small scale. They will see that 2 years. We are going to fund. Previously, it was 5 years. Now, we have reduced to 2 years. Now, this is a pilot project, actually. This is in a pilot scale, it will run. Then we will see how success is this. But definitely we will have a plan to launch after 2 years only.
Okay, thank you. Congratulations to the state of Kerala for getting HVIC. May I request all the panel members to come on stage? Okay, my first question is to Dr. Mukul Dubey. He's a scientist. So in a layman's perspective, why there is so much of hype about hydrogen? Why can't it be used like other gases like LPG, CNG? can you please just give the layman's perspective? Can you please explain the fundamental physicochemical properties of this hydrogen?
Yeah, thank you so
And
much.
also, if possible, you can provide the coding: green hydrogen, gray hydrogen, pink hydrogen, etc.
All right, so thank you so much for this question. We have seen there is a lot of emphasis on the green hydrogen. We have seen the state of Kerala's view, the center's view and everything. When it comes to energy, it becomes really a little bit of philosophical mindset. When you look into the periodic table, it's all about energy that we look about because energy runs everything. So if you look at the periodic table, you have got 118 elements out of there. But look at the God's choice, they have made the entire biological system using hydrocarbons, carbon and hydrogen entirely. And all the hydrocarbon is used as gasoline in fuels and everything. So the energy we derive mostly is from the hydrocarbon. So the calorific value, the heat value of the fuel that we use becomes really important. And the second consideration comes is the emission from there. So the calorific value of hydrogen is very, very high actually. It is around 120 megajoule per kilogram of hydrogen. Now, if you look at the same in terms of petrol and diesel, it is somewhere around 40. It is 3 times less. So that way, yes, the hydrogen, despite being the lightest and the smallest, tiniest molecule in the periodic table, has the highest heat value that we can use. Apart from the nuclear energy, which of course go to gigajoule. Now, coming to the emission side, we have, when we burn hydrogen, we get only water outside actually, water vapor. So we do not have the carbon emission, carbon dioxide, soot or carbon monoxide. So that way it is safe. So far as physicochemical properties is concerned, of course, tiniest molecule, it has got the boiling point around minus 200 degrees centigrade, which of course you must be studying. But then safety point of consideration, this physicochemical property become really important because it is highly inflammable. The flame temperature goes to around 3000 degrees centigrade. So we need to be really safe, and 4 to 75% of hydrogen concentration in the air can catch fire. So yes. So that way it is very important to understand that. The color coding based on the methods of production and the emission, we have different categories. The green hydrogen, which we all are talking about, has almost no emission of carbon into the atmosphere, which is derived from mostly the electrolysis, that is hydrogen production from water. The blue hydrogen is there, which of course uses natural gas with some carbon capture into that one. Then we have got gray hydrogen, which again has the hydrogen production from natural gas or coal, but it has got carbon dioxide emission into the atmosphere. The black hydrogen is of course the dirtiest one that we produce from the gasification route, burning of coal and all those. Then we have got turquoise hydrogen, which comes from the methane pyrolysis, and we get into the yellow hydrogen and the pink hydrogen. Pink hydrogen comes from powering through the nuclear ones, and the yellow hydrogen comes from powering from the renewable resources. So yeah, of course, hydrogen is a better fuel when compared to LPG and CNG because of the less emission and highest calorific value that we can have. Yeah, so that's all. Yeah, thank you.
Very nicely explained. And just to add on to Dr. Dubey's explanation, so when LPG burns, we can see a blue flame. When hydrogen burns, it's invisible. You cannot see the flame at all. So that makes it very challenging to use. So I think you agree with this one.
Yeah, definitely, definitely.
Thank you, sir. And next question is to Dr. G.V. Shankar, sir. Can you please provide the overview of the current innovations and technologies to produce green and other hydrogen at the industrial scale? What are the bottlenecks in adopting green hydrogen technology in industries?
We took upon a challenge when we got this opportunity. And I was given a very clear direction that we should go and approach this from an angle of production of hydrogen at an economical price, that we should address the issue of storage. We should also try to see if we can develop a base for power production and also see if we could divert, if we could divert a portion of the hydrogen towards dispensation. That's a very tall order. At the same time, the first thing we had to do was we had to fix the capacity. And we looked around, shopped for the right technology. And we got what we call as the Gulu technology out of Canada. And since it's a demo project, we decided to size the plant for 1,250 kg per day. And then to address the issue of storage, we went into metal hydride, which was the safest way to handle because it was not going to be under pressure. And the catalyst was so inherently attached to the molecules of hydrogen that it would absorb within its sphere in the porosity of the material chosen, in this case the metal hydride, and would be released on a thermal exposure on a need basis. You can store hydrogen forever and you will not have any problem because it is still not under pressure. Now you have to take out this hydrogen and be able to use it for power production, which means we have to develop a whole range of capabilities. In India, we have only one or two companies now focusing on that. And then we have the need for developing a stack, like was explained by Dr. Pai. The stack development is not an easy one, and today we have stacks that can be from an AEM base or from a PEM base. We found a very interesting Indian company, a multinational chemical-based company that had decided to get into making its own PEM membrane, and I took the initiative to, every time I would tell you, I had the pleasure of dealing with Dr. Jyothilal. You must remember he is an IITian. I'm from IIT Chennai and a chemical engineer. We could discuss many things, but fruitful advice from a technocrat and an administrator of eminence in this country, you will be surprised. You can get fundamental knowledge and try to see if such a knowledge can be implemented. And that's exactly what we did. We found this company with a PEM membrane and willing to make sure that such a membrane will be available for a potential stack in the future. That brought us into the capability matrix. But who is the Indian company who would absorb such a technology? We had the fortune, not very far from here, in the city of Tiruchirappalli, a company called the High Energy Batteries. High Energy Battery was exposed to the highest level of development in technology through its connectivity with the Ministry of Defense and worked for DRDO. And they did some excellent product development in the past. And they were in need of such a technology for high altitude situations. A perfect match, and we said, let's concentrate on the PEM membranes. And as that grew, we were able to get to a point, we had all of the parameters under control, but putting the stack together is one thing, producing power from that stack is another challenge. That's when we had to deal with the company from Switzerland. And this company decided to move its offices to the IIT campus in Chennai. And that became a boon for us because all control automation aspects that's required in this complex environment of being able to produce power we could do. And in their process, we were able to exploit the next phase, that is the power generation. But we were also given the requirement that 625 kg would go towards dispensation for fuel in an environment where presently cylinders loaded with hydrogen are used in the transportation sector in metro hydro or hydro metro. Now, we are going to replace that hopefully with support from the people from the shipyard who have built these ships in the past, but then they had to use hydrogen under compression. So there is a need for compressing hydrogen post-generation of power. A separate volume of hydrogen is being taken and compressed. So if you look at it, all these 4 individual unit operations, as would be described by a typical chemical handbook like the Maccabee and Smith or something, would explain each one of them as a unit operation. How can India maintain this as a new technology and be able to give it to the rest of the world? That was the type of vision that Dr. Jyothilal exposed me to. He said we should make the best and be able to actually sell this to other countries. That's when we started integrating each one of those control automation. Each one has got its own loop. And then you control all of them with a single control system using the latest of the control mechanisms. And that's brought the total thing into a technology component. So if you see the graduation, we were addressing production of ethanol, but that also has a challenge. Can we have enough biomass in India? And that was handled totally through another very good plan, because Dr. Jyothilal was also head of the forestry department. He said, why don't you work with them also, GV? And that's how that started. Today we are addressing energy crops that will be the feedstock production. That's a different project altogether. But unless we address in Kerala the issue of availability of this trend of thinking in energy, and that energy crops are made available, that was another opening for me. Now we have started to work with the forestry department. Now you look at the background of Axiom. Today we are a technology integrator in India, but originally we were only a company in the exploration area. But using AI, we developed predictive models to be able to use satellite imaging, to be able to develop the type of AI algorithms that will give the precise location for a critical mineral or an oil and gas. We applied it to agriculture. 14 parameters like moisture, the presence of fertilizer, the nutrients required, carbon in soil, all these were taken together, and with an AI predictive model, we have got that, and we are working with the forestry with a long-term approach. That's the type of fundamental knowledge base that you acquire with somebody like Dr. Jyothilal and the team we have. The team consists of our Chief Operating Officer, who is from the agricultural field, that's Sudarshan, and then of course Dr. Mukul Dubey with extensive experience in the US, and today we are helping even the company from Switzerland to establish the correct parameters. So this is the short and long of what we would call as a technology integration. And the latest we have gotten into, and we are going to attempt at the first project of DST for its 100 megawatt in Kerala, is the electrolyzer itself. If I can make the stack in India, and I have the necessary membrane, why can't I also make the electrolyzer? That unit will also come up in Kerala. With the full support and blessings, I am sure that we will be able to achieve this. So the integration of technology is a challenge only for people who don't have the vision. If you have the vision and you are supported by academia, the industry and the academia and the researchers can work together to make sure that we are the world leaders in this province, in this state. I use the word province because I come from Canada, and please pardon me for that. But on the other hand, vision is the real need, and the mission can be achieved by people like DST and others helping us and supporting. Thank you very much, and leave it to you.
Yeah, thank you, Shankar sir. Considering all existing current technologies, what do you think is the cheapest way of producing hydrogen? Is it SMR or water electrolyzer?
You see, the cheapest would be ultimately a technology that I think you, Mukul alluded to that, splitting water. But how economical would it be until that happens? Because by splitting using the energy that's needed, and if you can do that economically, you can even address India's national needs of water. Electrolyzer is a big challenge. Why? Because of the fact that as electrolyzers come up, water is going to be consumed. You can desalinate, but the cost of hydrogen is going to go up. And cost of hydrogen is to be maintained. So a combination of technologies is going to be the only way we can solve the issue.
Yes. Just to add to what Shankar sir said, to get 1 kg of hydrogen, we need 10 kg of pure water, distilled water. Is that correct, Dubey sir? Yes. Would you like to add to this?
Definitely. 1 kg of hydrogen, 10 kg of water. The water that you require has to be a deionized water. So consider the cost of the water that you put inside. So considering all the technology, the technology mapping that we have carried out, the biomass seems to be the most viable at this stage, of course. Electrolyzer technology is coming up very rapidly, and we are foreseeing that in the next 5 to 6 years, we will be having few technologies with better efficiency, low energy input use, and I think that will be competing with the other technologies. But as Jyothilal sir also has pointed out, and Pai sir has also pointed out, that in future we will be having to have a good energy mix rather than one single technology. Be it on the hydrogen side, wind side, solar side, we'll have to mix all of them together to get what we get actually. Yeah.
Thank you, sir. Shankar sir.
I have one thing to add, because we are in an educational institution, and Dr. Jyothilal referred to how researchers should work with students and as well with the industry. I've heard about a very interesting a statement that was told by a very, very elderly sage who I believe in, and I don't want to mention names, but I can tell you this is what he said. He who knows not and knows not that he knows not is a fool. Shun him. He who knows not and knows that he knows not is ignorant. Teach him. He who knows and knows not that he knows is asleep. Awaken him. He who knows and knows that he knows is wise. Follow him. There are a lot of such people in Kerala. We have to just follow the right steps. Thank you.
Thank you, sir. Thank you for the great insight. My next question is to Mr. Deepu Surendran. The marine industry forms the backbone of global commerce and is a vital sector. At the same time, the marine sector is also a significant contributor to greenhouse gas emissions. Can you give an overview of the green initiatives in the marine sector globally and also in India?
Good afternoon to all. As I said, the marine industry is the backbone of global trading. Around 80% by volume of trade is happening through sea. And most of the ships which are trading internationally are using heavy fuel oil as the fuel for its power generation. And this is a major contributor for greenhouse gas emission. And if you see, 3% of global GHG emission is from international shipping, maritime sector. And this has to be reduced. If international shipping were considered as a country, it would be 6th position as the GHG emitter. And that is a major contributor. And International Maritime Organization has come up with the initial strategy for GHG emission in 2018. As per that strategy, by 2050, 50% of greenhouse gas emissions from international shipping has to be reduced compared to 2008. But in 2023 July, this target was revised, and an ambitious target of was introduced in 2023. As per the new target, by 2030, 40% emission has to be reduced from international shipping, and by 2050, net GHG emission has to be achieved. Net zero emission has to be achieved. This is a very challenging target, and the only thing is to use zero carbon fuel for ships so that the GHG emission can be reduced. There are various regulations globally like EDI, that is Energy Efficiency Design Index, Carbon Intensity Index, and things like that was emerged because these are all classifying the ships whether it is energy efficient, what is the pollution it is produced. And there is another, European Union has come up with EU ETS, that is emission trading scheme. That is basically it is the world's first and largest GHG trading scheme that was introduced to industries and power sector. Now from 2024 January onwards, it is applicable for marine transport also for GHG emission. And EU fuel, that is that is introduced by European Union, that is applicable from 2025 January. That is basically it is applicable for ships calling on to European port for reducing GHG emissions. These are the various technologies or regulations internationally, and technologies like usage of zero carbon fuels like hydrogen, ammonia, or biofuel, and for short-haul transport, electrification, and if we are using low carbon fuels, then carbon capture and storage on board the ship. These are the technologies which are developing, and these are adopted by various ship owners, and it is in the international shipping, it is rapidly changing, that usage of different fuels. It is a mix of different fuels. They are not concentrating on a single, nobody knows which fuel will be, but ultimately it will be the hydrogen or its derivatives. And coming to India, India is having a vast coastal line of around 7,500 kilometers, and national waterways, navigable national waterways of around 14,000 kilometers, and around 12,000 vessels, registered vessels are operating in these waterways. But there are more than that unregistered vessels also operating. And all these vessels are using fossil fuels, and in India, if you see the domestic maritime emission is more. That also the coastal and inland waterways transportation is growing fast now, and it is very important that that emission has to be reduced. And the government of India has taken various steps, and various programs were announced. One of the main program is Green GTTP, Green Tug Transition Program. That is mainly applicable for tugs operating in ports. That is for the major ports in India. Presently around 100 tugs are operating in various ports, but all these ships are now tugs are using fossil fuels. And by introducing this GTTP program, it will be a phased manner. Initially, it will be with battery hybrid operated vessels. Then finally, it will be operating with alternate fuels like hydrogen, ammonia, or methanol. And the target is by 2047, all the tugs operating in major ports shall be with 100% green fuels. Another program is Harit Nauka program. That is a green transition program for vessels operating in inland waterways and some coastal routes. This program is basically for smaller ships operating in waterways, and the target is by 2047, all the vessels operating in the inland Indian waters shall be with green fuels. And another program is Harit Sagar program, that is for greening the port infrastructure by adopting green technologies and alternate renewable energies for the port operations. This is another program. And government has, Ministry of Port, Shipping and Waterways has also introduced subsidy program for shipbuilding. 30% subsidy for green ships which are using alternate fuels like hydrogen, ammonia, or methanol for the power generation of that ship. Then 30% funding will be given by ministry. And there is a National Center of Excellence for Green Ports and Shipping was also established by the Ministry of Port, Shipping and Waterways, and 4 organizations under this ministry, including Cochin Shipyard, is funding for that, and that center is in Terry, Gurugram campus, and Terry is running that National Center of Excellence.
Yeah. Of lately, I read a news about Cochin Shipyard launching, hydrogen-fed ferries. So is it the first case in India or elsewhere it's happening?
Yes, regarding this hydrogen fuel cell ferry, this is the first of its kind in India. And the most beautiful part is the complete technology is indigenous. 100% technology is indigenous. And the vessel was completely designed, developed and constructed by Cochin Shipyard. The fuel cell part, it is an indigenous fuel cell developed by KPIT. It is the basic technology is from CSIR lab. And Indian Register of Shipping is the certification authority. We all partner together, and that vessel was completed its trials in Kochi. Now it is deployed in Varanasi.
Thank you, sir. So next question is to Mr. Surendran Suryawanshi. Would you buy green hydrogen at the current rate, say 600 to 800 rupees per kg? What do you expect from the government?
There are many expectations from the government, and there are many expectations being offered also. Like Secretary Sir in his presentation and Dr. Ranjit Pai in his presentation gave idea about Hydrogen Valley and how government is taking various initiatives. And as Secretary Sir mentioned, we are really at the cusp of the energy transition. And even with the partnership which can be forged, and that has to become stronger among the industry, among the research organizations, academia and government. I would like to add to it as a CSR component. And for the research on the energy transition, or particularly for the green hydrogen, the industry should come forward to offer their CSR programs in this domain so that the speed can be achieved. Because I feel the speed at which we are moving at this energy transition is still very slow. And the 600 or 700 rupees per kilo of hydrogen is costly. And particularly where you make its use, whether you are using it in the industrial application or whether you are using for the automobile sector. For automobile sector, it may even work out break even, because as Dr. Dubey mentioned, because of the very high calorific value of hydrogen, you can still bring the cost equivalent to the EV or the diesel or petrol. So we are there. But as Secretary Sir mentioned, what our target is going to be is getting this cost of 700 to 800 rupees per kilo to under 200 rupees a kilo. And that's our target. And going further, it can be equal to $1 per kg. And this is achievable. And as Dr. Mukul Dubey said, bio-route could be one. Then I would like to add to there is the waste to energy. We have enough waste in the country, and that can be converted. There is a municipal waste, there is agriculture waste, there is industrial waste, which can be used. And Dr. Mukul Dubey was talking about the blue hydrogen and gray hydrogen and green hydrogen. And these definitions sometimes restrict to bring down the cost. But there are technologies available to reduce the gray hydrogen or convert gray hydrogen to green. How? By achieving your carbon goals. So you can get your carbon emissions reduced. There are technologies available which can be used where natural gas is being burnt or coal is burnt. With a single scrubber system, you can convert the syngas into hydrogen. But at the same time, all your SOx, NOx and carbon emissions can be reduced more than 90%. And those technologies are available. And one of the technologies that Axiom is supposed to bring, the first of its kind, will be implemented in South Africa in a thermal power production plant, where all the SOx, NOx and carbon emissions will be brought to less than 90% of the present technology. So if technologies like this can be implemented in our thermal power also, and also where hydrogen can be possible, from waste to energy or coal to energy, there you can make it green by using these technologies. And you bring down the cost of hydrogen, which is presently at 700 to 800 rupees a kilo, to under 200.
Thank you, sir. So we have almost come to an end. So one last question to everyone. Maybe you can take 1 minute each to answer this question. Will India be achieving carbon net zero by 2070? Are you skeptical about it, or are you optimistic? Maybe we will start from you only, sir, Suryawanshi, sir.
I'm very optimistic, and as I would always like to draw parallels with the solar. we never believed that solar would be used so well in the country and so many solar power projects would come up. And India would be able to achieve 200 gigawatt that we have the capacity today in the country. And we are talking of achieving 500 gigawatt by 2030. I would also draw parallel with ethanol. We always used to compare India with Brazil and whether we'll be really able to contribute 10-15% of blending that we do today, and we want to increase it to 30%. We can achieve 20% by 2027, and by 2030 we may go up to 30%. And that kind of ethanol plants are coming up in the country. And so these two sectors make me feel very optimistic that India can achieve 2070 carbon neutrality.
Yeah, thank you, sir. Nice to know about it. Dr. Shankar, sir?
I always go by a sense of what I call as cautious optimism. It all depends upon the leaders in the country, and we have got a good leader who is actually supporting innovation and such of those initiatives that are required. Like there is a combination of new technologies. The geothermal, what are we talking about? That can reduce. And one of the things that Secretary said was on the data centers that's going to come up. In fact, on the data centers, Ranjit also had mentioned about it. The data centers are going to consume some huge amount of power. But don't you see that the objectives that India is achieving in the energy sector of this 500 gigawatt, we are already crossed 290. That's a positive indication. If you exercise cautious optimism, we are still not there. We have to be there, and that's where the thing comes. We have got so much of thorium here, and who said thorium can't be used as a via media to be able to transport the geothermal to the top? But then you're getting into fission, and the problem in India is that we have administrative issues. It will not be allowed because the nuclear industry will come in. So as long as those barriers, that's why I'm hoping, hope against hope, that my neighbor here either becomes the MNRE secretary or the chief secretary and do both. We can't have such intellectuals sitting only in one place. We need a national consensus in this. That's my sense of cautious optimism. Thank you.
Thank you, sir. Jyothilal, sir?
As Dr. Shankar has mentioned, so it is three things. It's where there is a vision, mission and passion, it will happen. So 500 gigawatt when the government of India has announced, nobody thought that it is going to achieve. Like when we said 1 million EV, everybody laughed at, but it's happening. People are adopting it. So now the solar panels, the prices come down drastically. So I think it will happen. But only thing, as he said, continuity, vision, mission and passion, it will happen. And now this is only one of the areas. Like solar is one, offshore wind we never tapped. Now only we are thinking about it. You are telling about the SMRs and closed loop reactors. Another one is we have never, tidal we have never explored. See, tidal is round the clock. You are getting
Vast seashore, yes.
vast potential. And as I said, energy and matter are not different. And biomass, you were telling about biomass to energy. It's one of the cheapest form. I think we need to look at an integrated way.
Yes, sir. Thank you. Dr. Ranjit?
So as a clear, sign, you can see that Ministry of MNRE is launched now National Green Hydrogen Mission, and total outlay is, I guess, 19,000 crores with different initiatives. They have call for proposal was there, so you can see the hydrogen hubs are coming, testing facilities are coming. DST also come up with many initiatives like Hydrogen Valley Innovation Cluster, different call for proposal for hydrogen individual calls such as Advanced Hydrogen and Fuel Cell Program, bilateral program, several bilateral program. Now next month we are going to launch Indo-French call for proposal for green hydrogen. So definitely there will be a massive change in hydrogen economy. We hope that coming up with these 4 valleys, you see, initially we was thought that we will give 18 months for just to set up the infrastructure. Now, MNRE want to speed that. That is why we now 5 years reduced to 2 years, and the 5 years funding now we giving in 2 years, so that they can take this as a pilot project, then go into the larger scale. So, yeah.
Thank you, Ranjit. Mr. Deepu, sir?
Yeah, I also think that this will happen because there are a lot of innovations, research is happening in these areas. And as I said in the marine applications, already international shipping, the target is 2050 for net zero. And Government of India is also introduced various programs for domestic shipping in the marine sector. All these targets are coming by 2047. And with these policies, initiatives, and technology developments, I hope this will happen.
Yeah, thank you, sir. Dubey ji.
Yeah, definitely. I have seen the transition, as Sudarshan sir said, about the solar transition, heading the solar energy division at SPRERI since long. I have seen it has gone from 25 to 3 rupees per unit, which was initially felt to be not achievable. The installation capacity, the installed capacity has achieved its target much before what it was planned for. So things are happening, there is a huge motivation, and with the government support and the support from the industries like Axiom, international companies, I'm sure this thing is going to happen. But I will be telling you from the scientist point of view, working on the ground, and I'm sure many faculties, researchers, and students will agree on to this one, that it just feels like that I am pushed into the battlefield actually, because there is an urgency to it. The kind of investment, 10 trillion investment, of course, government is taking care of that. The kind of technologies, industries are taking care of it, but ultimately on ground, we have to work on it, work on war footing. If we all, like Sir was saying, academia, industry, and government, we all join hands, work together in good resonance, I'm sure this thing is going to happen. Thank you so much.
Yeah, all are optimistic about carbon net zero by 2070. Let us hope for it. So probably we'll be achieving it. Thank you all. And on behalf of whole Jain University, I would like to thank all the participants who came all the way here and be part of it. Thank you very much.
Thank you, Professor Mahaveer Kurkuri, for the moderation. And I'd like to bring our Honorable Dr. Krishna, NVH Director and member of the Chancellor's Advisory Board, onto the stage to present a memento. Also, Dr. Sridharamurthy, member of the Chancellor's Advisory Board from Jain University, to present a token of our appreciation to all gentlemen on stage. So many ideas, concepts, plans, initiatives discussed on this stage about green alternatives, green initiatives to fuel our sustainable future. As it was mentioned in the morning, we really hope that we have action pointers to take away from here, and we got lots of them in the session for sure. And it was a session packed with data, insights, so many points for us to take forward. Such an eminent panel from such diverse backgrounds, which also brought forth their perspectives. And finally, to our moderator. Yes. We request all of you to step up to the center stage for that one final group photograph with both our advisors. Yes, yes, sir.